Okay, hi everybody. Welcome to the special Halloween edition of Machine Learning Dublin meetup. We're very grateful to Huawei for sponsoring and providing some of the lineup for this evening's meetup. Thanks as always to Matthew and Claire and to Raoul for organising the logistics for tonight. So first up tonight we have Ali Karaali, who is a researcher in Trinity College and the ADAPT Centre, who's going to be talking about deepfakes. And then after him, we'll have Giovanni Laquidara from Huawei, who's going to be talking about MindSpore. And then his colleague William Zhang, product manager with the Huawei Machine Learning Kit, will finish off the three talks for tonight. So without further ado, over to Ali.
Okay, thank you very much, Declan. Can you guys see my presentation?
Yes.
Okay, so hello everyone. Today I am going to talk about one of my research, deepfakes, and how to spot them. So this is gonna be in the presentation. This is gonna be the outline of my talk. In the presentation, I'm going to talk about not only deepfakes, but also I will try to give a new concept in the area of deep learning. So what are deepfakes? Basically, deepfakes are the process of producing fake faces of real people. And one of deepfake type is the source and the target is the same person. So such as Barack Obama in this video. So let's watch the video first.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this, simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you. Stay woke, bitches.
As you saw in the video here, the target and the source is the same person, Barack Obama, and the goal here was to make him saying whatever the deepfake agent want him to say. There's another type of deepfakes. This time the source and the target are different persons. This method is also called face swapping. So let's watch a little bit of this video.
You've been over, visited me. I know your kids. Is this being passed on?
Yes. So, our 2-year-old right now, I'll say, how old are you? And she goes, I'm 4.5, which is her older sister's 4.5. And I go, no, you're not 4.5. And then she grabs my face and goes, 4.5.
That was also kind of a Schwarzenegger a little bit.
Yeah. I'm 4.5, father. Get out of here. Get out of this. The bomb in there. Get out. You got to go.
You've been over, visited me. I know.
So face swapping is basically changing a target's face by a source face. And here in this slide, Alison Brie's face is changed by Jim Carrey's face. Either deepfake models use GAN-based synthesizers, which include an encoder and decoder style network. And the process of spotting fake faces in video sequences is called deepfake detection. Most of the papers in the literature investigate this problem as a binary classification problem. They check the faces in videos and label them as fake or real per frame. Here, I just wanted to give a recollection about the general machine learning concept, how to measure the accuracy in a binary classification problem, just to refresh our knowledge. Most of the papers show their accuracies as the score of area under ROC curve, which is literally area under this curve, the gray area. The ROC curve is a curve that shows the relationship between true positive and false positive. There are many good methods are proposed in this concept to detect deep fake faces, and most of them rely on data. They are data oriented, and in order to label the fake faces, they use some kind of CNN architectures, and they classify the fake face images. But here I would like to mention about another interesting method. This method looks at the problem of fake face detection in the frequency domain. The proposed method checks the frequency domain if there is a difference between the real face and the fake face. To do that, the fake image is converted to frequency domain using discrete Fourier transform, which produces a two-dimensional plot. Then this 2D frequency representation is converted to a 1D representation using azimuthal integration, which basically takes the average of frequencies over different radius. Here it shows a 1D representation of a real image. So let's do the same process to a fake face image, and let's observe the difference. Here we can see 1D frequency representation of a real and fake face. I believe we can see here a clear difference between 1D frequency representation of the real and the fake face. Even with the naked eye, higher frequencies of the real image have some kind of flatness here in this region. So, based on these findings, a deep fake detection method is proposed, converting the image into frequency domain, taking the azimuthal average of over different radius, extracting the 1D frequency representation, and classify the face image as real or fake. This strategy is working quite well, even with an unsupervised manner. Here we can see a plot of 1D frequencies using a visualization method. We can clearly see a separation between real and fake faces. So why this behavior occurs? As I said in the beginning, deepfake synthesizers use GAN-based approaches, and those networks have up-convolutional layers. And looks like, although visually those up-convolutional layers do a good job, they somehow cannot manage to produce same frequency information as in real images. So we observe some kind of artifacts in the frequency domain. Here, there are basically two types of up-convolutional layers in the well-known deep learning frameworks: up-convolutional by interpolation and up-convolutional by transpose convolution. So basically, up-convolution by interpolation fills the gaps by taking the average of neighboring pixels, then filter it with learnable parameters. On the other hand, up-convolutional by transpose convolution fills the gaps with zeros, then filter it with learnable parameters. Either case, up-convolutional layer produces some artifacts in the frequency domain. Here's an example of this behavior. Here is an original image and the downsampled, upsampled version of the original image, which is the output image, using up-convolutional by interpolation and up-convolutional by transpose convolution. Either case, the output image has some artifact like high frequency or remote frequencies. We can see those behaviors in the filtered difference, the third column of the figure. So, in order to get rid of these artifacts, a recent CVPR paper proposed a spectral regularization term that regularized the frequency spectrum of those generated images. They use basically a binary cross entropy loss for the regularization term, using the 1D representation of the real and the output images. But there are some kind of interesting findings about this regularization. It is observed that in order to regularize the frequency domain, to get rid of those frequency artifacts, the filter size in the up-convolutional side of the network should be minimum 5 by 5. And even if it's smaller than that, it's not possible to recover those artifacts. So here are some takeaways from the presentation. I try to explain what are deepfakes. I also try to explain the types of deepfakes and how to spot them. Then I have mentioned about a problem when using up-convolutional layers of those famous deep learning packages. And I also provided a solution from a CVP, very recent CVPR paper to solve this up-convolutional layers issue. I hope you guys enjoyed, and I'm expecting your questions.
So I guess there's kind of an arms race that the better you get at upscaling and increasing the resolution of images, the more difficult it will be to detect fakes. So is there going to be an arms race of trying to get better detectors and trying to get better processing pipelines to generate fakes?
Yeah, the problem here, if you use these up-convolutional layers, like that's why this method is very accurate. Actually, there's a clear difference between real and fake faces in the frequency domain, and they say that this difference is coming from the up-convolutional layers issue. So if you solve this problem, it's going to be harder to detect this difference, and it's going to be also very useful for some other methods to produce training images, because many methods now based on synthesized training images using GAN-based approaches, right? So it's going to be very useful to use this kind of regularization term to remove those frequency artifacts. That was the main issue here.
I imagine there's more research being done into like generating better images, so there's more applications for upscaling and for image modification than there is for detecting it. Do you think there's going to be a disparity between the two sides?
It's going to be harder for the detection part, yeah, as you said, because using removing these artifacts in the frequency domain is going to make the detectors work harder, like it's going to be difficult for them. But for generation, this is good. I mean, you can produce, like, for example, images or deconvolution, for example, using deep neural networks. You will produce better results, like more visually they were better already, but like in the frequency domain, if you check, you will see your results will be closer to the real ones.
So what do you think will happen in 5 years' time? Do you think we'll still be able to detect fake images? Or
that's why I believe people work on producing fake databases, because currently, like till 2020, the accuracy of the databases was around like 99%. But now there's another CVPR 2020 paper. They produced a database, new database, celebrity fake database. They are swapping the faces of famous people, and those accurate deep fake detectors, it's like the maximum accuracy is around like now 60%. So it's getting challenging as well.
So a question from the chat is, apart from the potential for disinformation, what are the applications for deepfake technology?
I guess the Obama's video was very useful for an application. They try to cheat people with fake information. And if you see a political leader talking about something, so you should be suspicious now because of deepfakes. I think this is the main application. Another application would be, I didn't see that, but just now came to my mind, maybe some kind of like famous or like famous people, they can teach some kind of like, I don't know, English literature, Irish literature, or math or geometry to children, like synthesize from like synthesize text, you know, like it can be used as an application.
I'm not sure what, I think the Star Wars movies have very impressive face swapping or making people younger. I suppose there are like more legitimate uses for it.
Well, I haven't read about that. I'm not sure if they do some kind of photoshopping or they use some kind of machine learning application to change the faces. I don't have information about it.
So I think it's the Marvel movies and the Star Wars, all from Disney, have de-aged actors and improved a lot in the last 2 years or year.
And the Irishman as well. They have loads of it.
I couldn't find time to watch Irishman. It's too long.
Fair enough.
So another question is, how can we distinguish between fake and real apart from using the frequency domain? Are there other solutions?
Yeah, there are. I didn't want to give details here, but there are many, like, let's say black box, CNN black box here. They are changing the architecture. It's like just playing with the architecture. It's like classic CNN networks. I wanted to give this frequency method because to me it looks more interesting, and my research is in the frequency domain as well.
I suppose it also helps a lot with interpretability. If you have a black box telling you that it's a fake image, it's how much faith can you have in that?
True. It's hard to find a deep learning paper that does some kind of plot like that, you know, like, oh, you can see like a clear separation between classes. It's hard. Interpretability is hard, like with deep learnings.
Okay, any more questions for Ali? No? Okay, well, Ali, thanks a million for that really interesting talk.
Thank you very much. Thank you very much.
And so next up we have Giovanni Laquidara from Huawei. So I'm looking forward to hearing about MindSpore. Over to you, Giovanni.
Great. Let me see if you see my screen now. Yeah. Can you see my slide? Yeah. So yeah, hi everyone, that's me. I'm Giovanni Laquidara. I'm developer advocate in Huawei. And in the past, I was doing some software development in the defense field and Android application. And also I had fun in many conferences and meetups speaking about machine learning and augmented reality. These are things that really interested me a lot. So first of all, today, let's see, before introducing the topic, I want to announce that we have, like in Huawei, organized 3 contests for you. So the first one is super easy to join, and you can win some good Huawei USB-C earphones. And to do this, I will explain this in a bit. Then we have other 2 contests that are more developers oriented. So you need to develop an app with it. So the first contest is all about signing into our developer forum. So the forum, you can find the forum here at developer.huawei.com, forum.developer.huawei.com. And you have to look for that post about this meetup, so machine learning meetup. So I will say again, so forums.developer.huawei.com. You just have to sign in if you have already an account, otherwise you have to create an account. Then you have to look for the post referring to this meetup, so machine learning meetup, click on it, and then you can add a comment to join the raffle to win the headphones. So they come to here there are the rules, but you need to answer 3 simple questions about it. So it's very easy. And then the second contest, this is a bit more complex. So if you have an app in the Google Play Store, so we are talking about an Android application that already have more than 50,000 downloads, you can develop the same app for our app gallery. That is an alternative store that Huawei is using for its HMS phone, so the phone that are not using the Google mobile services. So if you have this app, you just can contact my workmates. So I left in the slide their emails. So you have to just indicate the app category, the package name, the app name. And you have to convert your app from GMS to HMS, but it's a really simple things to do. And my colleagues also will help you. So if you develop your app into our app gallery, you will automatically receive one of our best smartphone ever, the P40. This is the second contest. The third contest, it is, here, let me see the slide. The third contest, it is for the creative developers. So what do you mean? What does it mean? It means that if you have an innovative idea for an application, just develop it. We can help you with that. You can contact me by mail, or you can contact my colleague, Johnny Zhang, by mail. He will help you to create your project. And then you have to share the GitHub repository with us, with the project introduction. And in the next meetup, probably this or other meetup, we will present your idea and you will automatically win the P40. So it's another contest, another opportunity to receive a really cool smartphone. Just develop your app. And also an important thing, the next presentation will be really useful for you if you want to use ML kit and machine learning into your Android application. But let's focus on the things that I want to present to you today. So yeah, the topic of today is MindSport and MindSport Lite. So MindSport and MindSport Lites are our framework that helps you to build machine learning models and run them on smartphone and IoT devices like wearables and so on, and allows you to create your model adaptable for all the scenarios that you need. So it's a really powerful framework. If you, let me see, yeah. First of all, I want to a little bit to recap about what are the trends and the challenges for the on-device machine learning nowadays. So nowadays, we see that 3 main things, 3 main issues, 3 main challenges. The first one is that we see that the number of parameters in the models are exponentially increasing, exponentially growing. We passed that from BERT to GPT-3, and we saw an exponential growth of the complexity of the model and the number of parameters. But secondly, we see that, I mean, yeah, the parameters are growing, but if you want to run the machine learning model into the device, it's a little bit complex because the smartphone and wearables are really limited resources, so a small amount of memory or RAM memory, small amount of battery, so you will need to look for a low consumption. That's it. It's a problem. It's a challenge. And secondly, we are seeing that we have like 2 kind of way to deploy your machine learning model. The on-device one, so you can deploy your model into your wearable, into your smartphone, into your earphones, maybe. And then we have like the cloud AI, so the model deployed on the cloud. The device one will assure to you privacy, because the inference will run only on the device, the data will be contained on the device. There is no problem with the privacy issue because your data are not transmitted in the cloud. By the opposite part, the cloud will handle your data if you want to deploy your model on the cloud. But the problem with it is one of the privacy, it's the privacy problem, but the cloud will allow to you the power of the platform. So you will see an increase in maybe larger and bigger model size. And the third aspect, the third aspect is that we are seeing a machine learning model everywhere, from smart speaker or smartwatch or earphones, like I said, that are devices that have limited resources, memory, battery, and other things like that. So to tackle these challenges, we created a framework for machine learning. And we are trying to solve and optimize these challenges using MindSpore and MindSpore Lite. So what we created MindSpore, and MindSpore is a framework that helps developers and data scientists to build their model, and will grant to them to be able to easily integrate into their apps with fast, small, and easy way. Faster because we thanks to the collaboration between hardware and software that a company like Huawei can grant, because we are producing both. So we are able to increase the performance of running a model, running an inference on the device. Smaller because with MindSpore, we can optimize with the quantization process, the compression of the model, and we can balance the performance with the resources. And easier because we developed a set of tools that will allow the developers to easily define the model, train the model, and also run on the devices. And also MindSpore offers a Python API, so really easy for data scientists to use because it's something they already use too. And MindSpore is optimized for computer vision and for natural language processing, that are one of the most used models and kind of model using IoT devices. And you also can convert, if you are coming from TensorFlow, Caffe, and other frameworks, you can convert your model into MindSpore with our tools. So let's see the key points and the architecture of MindSpore and MindSpore Lite. So first of all, MindSpore Lite is based on MindSpore. So it is just a subset of the environment, of the MindSpore environment. It is fully developed by Huawei from the ground up, from zero, and now it is open source. So you can check the code. It is designed to be used from the edge to the cloud. So it's supporting the chipset of the wearable device, the IoT devices, but also support the GPU. And obviously support the Huawei Ascend processor. That is a hardware, a chipset specific designed by Huawei to train the models and for machine learning. So it's a really high-end chipset for this, running on the server, on the cloud. The first layer of MindSpore offer, like I said, a Python API for programmers, easily to use, but we are also thinking about expanding this set of API to use C, R, and other languages. The first layer also includes support for an intermediate representation of the code. We are calling this MindSpore High-R. So your code will be like translated into a sort of internal code for the model. In using this MindSpore High-R, the optimization will be processed. And also we are using a graph engine layer that offers the necessary, the needed functionality to create and perform the automatic differentiation for the execution graph. MindSpore, different by PyTorch or TensorFlow, is using an automatic differentiation model. So it's really different from the approach that PyTorch and TensorFlow has taken. So MindSpore Lite, so it's a subset of MindSpore designed specifically for to be optimized for wearable and smart devices, and offer a series of optimization to your model defined to be defined and trained into MySport. And for example, it supports preprocessing and optimization, lightweight inference engine for on-device learning capabilities. So you can perform learning on the devices. That's something that is really powerful. To optimize, if you want to optimize the model from MySport to MySport Lite, we are supporting graph optimization. And with this, we are using pattern-based operator fusion. And you can optimize your model using Strassen and Vinograd algorithms. And also we are support specific hardware extraction that you can use if you are using dedicated hardware. So let's see if you are using like a specific chipset and you want to run your model into that chipset, we are offering the specific extraction to run your model there and to be optimized there. The model trained by MySport and MySport Lite is enabled to run now on Kirin, MTK, and other chipsets like ARM or x86 chipset. And we are using a particular low level acceleration to enable the natural processing unit. So if the device where you want to run your model as an NPU, a natural processing unit, you can be sure that using MySport Lite, your model will be optimized for it. We just released the version 1.1 of MySport and MySport Lite that improves really good the performance into the ARM CPU and x86 CPU. And you can see from the graph here there are the inference time of an optimized model running into the Huawei P40 chipset, so the Kirin 990. That, by the way, this is the smartphone that you can win if you are joining our challenges. So we are constantly improving the performance on the model running on this chipset and also other one. To achieve good performance, we are continuously optimizing it, and we are using the adaptive mixed precision quantization tool. It's a tool that can really perform quantization of your model and can optimize it. So you can use this tool to obtain your quantized model and run it on a device that has limited resources. So like I said before, headphones, smartphone, wearables, whatever. The MySport runtime is also like an ultra lightweight because we are using what we call the model as a code process. What does it mean, model as a code? That the model that you can produce with MySport Lite will be generated like and contained into a C file. So a single C source file that you can compile into an executable, and then you can run your executable and deploy it into an IoT device. Often the IoT devices they offer a developer platform that's capable to run C program, C software. So this is really optimized for it. And with MySport Lite, we support model from other frameworks. So if you are user to get other frameworks like TensorFlow and other, you can use our converter tool. We will see in a bit the video about how to do it. And also we are supporting GPU, CPU, and NPU. And many OS, like not only Android and iOS, but we are supporting Windows too with MySport Lite, and we are supporting the next brand new operating system from Huawei, Harmony OS, that is a distributed operative system. So if we allow your model to run throughout all the set of device, from smart TV to wearables. And we are also supporting Light OS, that right now is the OS running on the Huawei smartwatch, like the GT Pro. And we are supporting advanced features for it, like on-device training and quantization, like I said before. If you want to use MySport Lite, you need to know that we are supporting many operators. Especially now we are supporting more the one used in particular for computer vision. And by the end of 2020, we will support more and more operators to be able to use all the models that you need. And yeah, if you want to know how to build the things with MindSpore, it's easy. You just need to use the MindSpore Lite tool chain, and a model developer can perform easily a model conversion or design its own model. It can deploy it on the, it can deploy the model on the MindSpore Hub, that is like a big repository of all the models that you want. So you, as a data scientist, you can deploy your model there, and then you can tell your friend that is an app developer, maybe, to use that model. So this developer can download it and can, using like HMS ML kit, that is one of the kits that you will see in the next presentation. So using this SDK, it's very easy to use as an Android developer or an iOS developer. So you can use this one, and you can download the model designed from your data scientist, and you can easily integrate that machine learning model into your desired app. Also, to convert a model from TensorFlow into the, for example, into the MindSpore Lite, you can use the converter tool. And a developer using the converter tool, that is like a super easy command line tool to use. It's the developer can perform a post-training quantization without retraining the model. And this is supporting, this quantization is supported also, is supporting also weight quantization and full quantization. So it's helping you reducing the size of a model with nearly no accuracy loss. It's a little bit of accuracy loss, just a few. And now let's see what is to develop a smart application with MindSpore Lite. You can decide between 3 paths. So you can easily select one model from the ML Kit hub, that is another hub we are dedicating to the deployment of the model, or you can decide to download it from the MindSpore hub. And in this hub, you can also upload or download the model. If you are downloading the model, you can perform a personalized training on it, so to modify the result and tailor the result to your needs. And to integrate, you just need, you probably want to optimize and convert your model to run into a particular device. And then after that, you can deploy your model using MLKit on MindSpore Lite SDK, and then just run your model inference into the device. I have a little bit of a video to check with you how it is to use the converter tool. So just take your model, and then you will have the command line. You can call the converter Lite, comma, and then let's say you have a model that you want to convert into MindSpore, and that's it. You just, with one line of command line, converted it. And then this converter Lite supports many options if you want to perform quantization or receiving model input from TensorFlow, Caffe, or Onyx. We are supporting this. Then you just need to upload your model into your application. This is a classic Android application, for example. You just need to change the name of the model that you are using. So if you want to use another model, just change the name with the one that you already produced. And then you can have actually the sample code of this application into the MindSpore documentation. And then if you run the application into your device, in this case, we have like ImageNet model converted for MindSpore Lite. You can see that your application is really, in a simple way, working. And you have to develop really only some lines of code, really simple. So develop with MindSpore and MindSpore Lite is very easy. I want to show here there are the main documentation and the website. So www.mindspore.an on .cn. And also remember that MindSpore Lite is also open source. So if we check, we can check the code. This is the main website of MindSpore. And then if you want to check the code, you can go on GitHub or Git. We are supporting both the repository environment. And install MySpores is really easy. You have to select the version, the platform where you want to run the MySpore framework on, the operating system, the Python version is predefined, and the way you want to install the MySpore, so from source or from PIP. And then it's really easy to install. If you want to check the tutorial, we have the very simple tutorial about how to create an image classification application. And you can check from the code here that the API is really coming from other framework. Really easy to define your network. The operators are really familiar to use, and then you can produce a model that is really optimized for the platform you want to run your application with. And if you want to know more information about it, you can contact my colleagues, my workmates. I have the email here in the slide. And also, if you are interested to develop more business app for it using MySpore and MLKit that you will see in a bit, you can easily contact me or the other guys, and we are very, very happy to help you. So yeah, if you have any question, I think this is it for MySpore.
Cool, thanks, Giovanni. That was really
Thank you.
interesting. Actually, a couple of questions came in on the live stream. So, so first off, from Nikhil Patil. So, first of all, he wants to know: can we develop the app in Java or Kotlin?
Yeah, actually, you can easily develop your application in Java and Kotlin, your Android application. So, if you're speaking about Android, yes. If you're running iOS, yes, you can run your application with Objective-C or Swift. You can run your application whatever you want, but we are offering the SDK to interface and load your model, your machine learning model, and running your inference. So develop whatever language you want to use. If you want to use C, it's okay. But the most important part that you are offering the layer, the API to interface with the machine learning model that you want to deploy.
Sure. Okay. He also asks about the in-app purchase options on the platform.
Yeah, we are offering like feature and capabilities about using in-app purchase. So our platform is really offering the same functionality that you can have into the other operating systems, so iOS and Android with Google Play services. We are actually now using Android, and we have the layer that is supporting in-app purchase, analytics, machine learning, barcode scanning, location map, everything that the developers need.
Mm-hmm. Okay, and then his follow-up question was really about reach. Now, this is a relatively new platform, so I presume the reach is not yet going to be as vast as it is for iPhone or for Google itself. Do you want to just talk a little bit about that and how it's growing and so on?
Yeah, right now we are like yes, the reach is not like the two main platforms, so Android and iOS, but we are like the third ecosystem. And we are constantly growing. You can see in just 1 year, we've grown a lot. So there are a lot of applications into the App Gallery and that are offering the same functionalities of the Play Store. And also we are trying to build an ecosystem that is really open. And with open, I think about will allow the developers to interface really easy with the other device, because we think that the future of the device will be not only the smartphone. We have like a strategy where we call 1 + 8 + 10. So the 1 is the smartphone, but the 8 and the 8 are like the most common devices that are surrounding the smartphone, like the intelligent car, the wearables, and the hen is like the IoT. So many sensor interfacing each other. So we are trying to build a layer, a software, and then also in the future an operating system that will support easily to create application for this vision. So easily.
Cool. Okay, that sounds great. And Kashif asks, can we develop and deploy models offline?
Yes, you can deploy your model offline, so into your device, and then you will have no problem with data exchanges by the network. So it's really easy to use. Just integrate into your application, into your asset folder, if you're using an Android app, and load it. So, or we are offering also the cloud layer that, let's see, if you want to update constantly your model, then you have to redeploy your application. And in this way, if you're using the cloud, you can make your application perform the download of the model from the cloud. So it's just a developer choice.
Mm-hmm. Cool. Okay, so that's it for questions, I think, Giovanni. So thank you very much for that really informative talk. So last up for tonight, it's William Zhang, who is the product manager with Huawei Machine Learning Kit. So William, are you ready to go?
Yeah, I'm ready. So
cool.
Just to share my screen.
Okay.
Wait a sec.
Yeah, you can see that.
What? Yeah. Yep. Can you see my screen?
Yep.
Okay. So, hi. I'm William. I'm product manager of Huawei AI Services. Today, I'm honored to share with you some kind of new ideas about AI exploration. Huawei has been always committed to development of technologies. During our continuous exploration of the final form of AI, we have been asking questions that many people will ask. What kind of form will AI eventually appear in our lives? We have many wonderful ideas and great visions. However, as far as we are concerned, mobile services or wearable devices will be the easiest way to interact with our daily life. The AI capability of mobile devices are the world's largest AI window. Of course, the challenges are huge. The AI capability of mobile devices not only means the smaller and faster models, but also means the continuous updating and tech evolution of the entire AI mobile framework. Now, there is another trend. It is estimated that by 2025, smart speakers, cars, mobile phones, PCs, tablets, and head display will all have AI capabilities. By 2025, the AI production capacity will exceed 50 billion US dollars, of which the AI chips on mobile phones account for more than half, reaching like 26 billion US dollars. The value of AI on mobile devices will be increased, and AI collaboration between devices will become the mainstream. And mobile AI has become a strategy for countries. Investments in various countries drive large market demand and are all in period of great development. So let's have a brief look at what is HMS Core. Many people will ask these questions. Okay, so we are built on the OS operating system in here, and we provide capabilities like the account location and machine learning, vital health kits for the HMS apps. Yeah, we're in here. So here's the Paroma service Paroma. Since the release at the end of last year, we have gradually expanded 6 services to more than 20 services. By category, the models can be classified into 5 types. As you can see, the text services, the image services, voice, face, and person, custom model. The text type mainly recognize text and image and the various cards and card numbers. Image scenarios are rich, including like basic image classification, object detection, photoshopping, image segmentation, and image super resolution. Speech includes like speech recognition, text to speech, and translation, which can be combined into like intelligent functions as simultaneous interpretation and voice assistant. Face detection and liveness detection in human face category can be used for face payment and online authentication. Skeleton recognition, hand key point recognition continue to focus on interactive games and fitness scenarios. The custom model provides developers with the brand new model training mode. We build on the MindExploits we can just mentioned by Giovanni. There are many interesting AI scenarios on mobile devices. Let's just have a brief look at the simplest live scenario. Take photos to extract a text. What are the possible courses? For example, if you are a paper document in a company, you have a paper document in a company, and you want to import the text into your computer or bind your bank card by taking photo. But getting the most accurate text recognition result is not easy. The intensity of the illumination, blurring, staining, deformation, and other factors can cause problems with the final result. So how can we solve this problem? Now, let's look at the first small function, document crew correction. It is not only support documents, but also related cards, receipt, road maps can be corrected. In short, it is to restore the deformed document objects. We've tried many methods to implement this function, and here we have summarized 2 valuable technical ways: multi-channel linear detection and real proportion prediction. These 2 patents proved to be great help to solve the problem. First of all, in some complex scenarios, for example, when a file is placed on desk, it is easy to be mistaken for the side of the file. However, use multi-channel linear detection or confusions in multi-linear channels and select the high score from the selected value as the final output result, which proves to be a significant improvement for the final result. As you can see, like if we use the traditional Hopf algorithm, it can be easily mistaken the age of the desk to the age of the paper. The second is how to convert the candidate region into the result before the deformation after we obtain the corresponding candidate region. We synthesized an influence model and then fuse with the estimated deformation proportion to get the compensation factor. Yeah. Now we have the corrected document, and next step is to perform resolution operation on the images. There are still a large number of low-end devices in the market, and the image resolution is not that high. In this case, we need to use image super resolution function to enhance the resolution. Image super resolution, as its name suggests, is to enlarge the original size of the image. Currently, Huawei supports 3-fold magnification. The size of your of our model package is very small, even like 1/10 of the size of other products in the market. For device side, the size of a model package is critical. which can directly affect the running speed and even the download volume of the app. We also have the separate text super resolution model for the text classes, which can be better used to improve the document. Image super resolution is widely used in news apps. Users can directly use image super resolution when clicking an image to zoom in without downloading larger images from the cloud. This feature greatly improves the speed of the images on the device side and save a lot of storage space on the cloud. Besides amplifying the definition, we can also use our self-developed GAN network to solve the four most concerned issues in the industry: contrast enhancement, detail enhancement, color enhancement, and noise reduction. The last but the most critical step is text recognition. Our text recognition function is powerful, mainly reflected in the ability to recognize curved surfaces and tilt objects. In real life, many texts are curved. For example, the text on the pillars or the bottles. Text recognition is widely used in education tools, such as photo translation. Once you use in the dictionary, it's really widely used function. And supposing you are in the foreign restaurant, you don't know the text on the menu, and you cannot type the text of a translation. So you can pick up your phone, take a photo, and use text recognition, the translation function, to solve this problem. Others including inputting receipt information into system. Yeah, there are many of the typical scenarios of the text recognition. So here's the customer case. Let's have a brief look at it. Favors the Malaysia app and help users to find the best price for products. One feature is to scan a specific serious number to get obtain the coupon. As shown in the demo, the system identified information prefixed with faith. Once the information is found, the corresponding discount page will be displayed. There are some apps. This is about the simultaneous interpretation. So in these typical scenarios, we can break down the whole AI functions into 3 steps. First is speech recognition. You're going to first recognize your voice and translate the voice into text, and then you do the translation to translate the voice and text into the target languages, and then you do the speech, you do the voice synthesis. So let's have a brief look at the speech recognition, which is the auto ASR. So here we can see there are 3 typical scenarios. First is the voice search. As we can see that the text search, the text-based search, can be always been replaced as to the voice search. And second is the voice shopping. We see, as we can see, that the smart sound has taken more and more important status in the market. And we notice that the voice shopping is becoming more and more popular. The voice shopping is not, as we previously think, it's about it's not about to buy something new. It would be a disaster. It can be used in once you have bought something, you buy twice in these kind of scenarios. And we can see the ASR, the voice speech recognition in social chats. As we can take me as an instance. My mother always sent me like 60 seconds language voice message to me, and I don't really want to listen to that, so we can just use the voice ASR to translate into text and read it. So here's the technical steps, technical part of the ASR. So first is we extract the speech features, and then we pass the features into through a lot of models like the acoustic models and language models to get the right information, and we do the decode services. And it's really easy to get integrated. We only need like 3 steps, and all the integration phase would be within like 30 minutes. And next, about the text, the voice synthesis, text to speech. It can be used in the map broadcast, in the navigation apps, or in the reading apps, or can be used for the virtual broadcast. And the whole step is pretty much like the previous one. And first is do the feature extraction, and we pass it through different models, and then we get the do the fast inference to get the right result. The final one is the translator. So we can use this the subtitle translation. We can combine the translator with the speech recognition once we recognize the voice in the movie and do the translation. It's pretty easy to understand. And it's going to be a little bit complicated because we concerns about lots of languages, and different languages will be in different models. So the whole technique stack will be a little bit complicated. And temporarily, we support 12 languages on the device side, and 21 languages supported by the cloud side. There are also some apps that are closely related to images, for example, photo retouching and live broadcast. As we can see, once we look at our faces, we can see that these 3 functions are based on the facial detection. For example, special effects can be used based on the detect facial content information, such like the nose can be replaced, the detect nose areas with the cat nose for the 2D sticker. It is worth mentioning that our facial detection can provide 845 key points for detection, which can be more accurate in selecting the corresponding face area. Secondly, we support the 3-dimensional face orientation. The X, Y, and Z face orientation can be returned. In addition, 7 expressions such as happy, angry, and doubtful can be supported, and it can also support detection whether your eyes are open and closed, whether you have a beard, whether you wear a hat or glasses. On the right hand side is our open source demo using face detection for 2D sticker. A common scenario of image segmentation is background replacement, not only for images but for videos. In the current society, short videos like TikTok and live broadcast are very popular. In this case, real-time video background replacement is very important. Therefore, we can use the self-developed CRF networks to achieve hair-level matching on videos. In addition, we support not only human segmentations, but also 11 types of other objects. For example, you can replace the mountain, water, the sky in real time, just like here. Currently, image segmentation in the industry has always been difficult and challenging. For example, data labeling can be very expensive during the multi-category image segmentation training. Therefore, we use the weak labeling search. We will use some kind of label data and use attention mechanism to generate the mask to label a large amount of new data. The second problem would be like the actual environment is complex. So therefore, stable and high precision segmentation cannot be correctly output in changing illumination or background scenarios. To this end, we design an improved network code such as CRF to achieve high-level image segmentation in video. The third one is that blank occurs during video processing. Therefore, the time information is introduced to solve the problem. So we do a lot of the consistency constraints to solve this thing. So let's just go to the next chapter and have a look at the online shopping scene. We know that the online shopping on mobile terminal has become a trend, and the proportion of mobile entry transactions will be further expanded. Therefore, the AI shopping experience on mobile devices is becoming more and more important. The traditional shopping process is to enter keywords to search, but imagine these scenarios. Imagine the scenarios. While you're watching TV, you find your favorite movie star is wearing a really nice dress, and you don't know where to buy it, and you don't know how to buy it. So, but if you have the product visual search, you can have just have to take a picture of the clothes, and then we will return the most similar items sorted by similarities. So, or users who find some overseas goods but don't know the name also can use this function. Currently, we support 14 categories and hundreds of subcategories for product visual search, covering almost all goods types on market. Our product visual search features include three main advantages. The first one is the full product coverage, as we just mentioned. The second one is the high accuracy in complex scenarios, such as in the low definition images or complex illumination condition. The third one would be like we can ensure the highest level of data security. The main technologies can be break down into 7 aspects in product visual search. For example, at the task level, we need to break down the several parts that need to be implemented in product visual search. We also focus on the model selections and optimization, good similarity ranking, and the loss function definition to ensure the result is the result will be the optimal choice. We have taken a variety of data collection methods to maximize our training data, and we also used some key acceleration technologies on the search engine. The end-to-end latency will be ensured. Let's look at the overall invoking process. When a user chooses to invoke a product visual search, we'll first perform a detection to locate the specific position of the object in the image, and then perform an kind of a intent search. For example, if we detect it's from a shoe category, a shoe features extraction network will be used. Next, the feature extraction and feature compression are performed, and the matching result is matched with the offering the features in the base library. And finally, the optimal result is returned through the operation such as reordering and deduplication. Therefore, if a commercial company want to use the product visual search, they don't bother to build their own services. Simply invoking our API would save lots of human and computing resources. And currently, we have cooperate with Banggood and other companies on these services. And it is proved that number of users and number of downloads have increased after using our product visual search. The function has achieved a really good result. So let's have a look at the demo. So once you take a picture of the of Huawei phones and will return the similar goods. The most interesting part came in my favorite parts. From the 2004 classic movie I Robot to the latest Her Samantha and Our Man Jabez, AI has not become more intelligent, but also its form and carrier are not limited to machines. In terms of interaction, Huawei hopes to create a new generation human and computer interaction with digital person. AI capability enable digital person to be applied to scenarios that require a large number of repetitive label and massive and complex computing, freeing the human resources and improving productivity. The users only need to provide a piece of the text information to get a reading video by preset model. For example, we also support just like the video show. Yeah, of course, we also support custom images. You can customize your own virtual figure by reordering a recording in advance. We can also generate 3D animated characters. Ultra HD 4K cinema level effects make body details more authentic and refined. The digital human synthesis is highly realistic. It can reproduce the reflection of details of the teeth, lip, and even the lipstick. It can reproduce the light, the contrast, the shadow, and dimple of the face. The digital person is almost a recall of the real life, a real person, whose appearance, expression, action form is so realistic, and the tone, speech style is nature and fluent. Huawei use powerful AI technologies such as image processing, speech synthesis, sound cloning, and semantic understanding. Digital person can provide high quality, low cost, and innovative content creation model for the education, news, and multimedia production. The emergence of digital person is just a microcosm of the industry intelligence trend. As the pace of industrial transformation and upgrade accelerates, more and more digital person will emerge in all industries. So the core is like the voice training. The core tech is like voice training by tens of thousands of humans and various voice parsing. At the same time, the lip network is based on the latest deep learning technologies. The lip expression is nature and realistic. Huawei developed the multi-scale GAN network generation technology supports 4K level neutral nature, clear and vivid details, and generate background can seamlessly blend images. And finally, let's look at the overall value of Huawei mobile services. We have worked with more than just take the AmeriKit as instance. AmeriKit has worked with more than 1,000 companies over the past 10 months. In summary, our services have the following 4 core advantages. The first will be the full coverage. It supports not only all Android phones, but also some services support iOS, TV, and tablets. The second is free of charge on device side and limited free on cloud side. The cloud side has quota every month. The service will be charged only when the quota is exceeded. The third is very simple and easy integration. Quick integration can be completed within 20 minutes. And the fourth one will be the collaboration between the NPU and CPU to ensure the motor speed. Yet all the AI features was built on the MindSploit. So these basic technologies can ensure the whole model will be the farthest. So that's all for today's sharing. Huawei has always practiced in science and technologies for good. We also hope you can join us in building mobile AI together. Thank you.
Great, thank you very much, William. I think Declan has had to drop off the call. And that was really fascinating presentation. Thank you very much. So I can see we have some questions here, I think, on YouTube. So there's a bunch of questions here from Nikhil Patil. So I'll just take the most recent one, work my way up. Does Huawei provide any type of grant or credit help for the AI startup if they use ML services?
I'm sorry, I couldn't see the questions in the chats. Could you?
Oh, sorry, I'll add it in here. Yeah.
Grant or credit help to AI startup if you use ML services. We only can provide the it's like how to say about that. We provide free SDKs. That's the thing, and if we can encourage them to join our contest, and if they win the prize, they're going to get lots of free exposure of the apps or get the incentive. I think that's it. All the services, all the features we just explained will be free of charge.
Okay, great. Thank you. Got a bunch of questions here. I'll just copy them in.
And also we because we only provide the SDK integration, so you don't have to worry about the algorithm, how to train the model or something like that. We have all encapsulate all the models and the bunch of things to get in the SDKs. What I'm gonna do is just invoke the SDKs and like take 10 minutes or 20 minutes to use our services. Yeah.
Yeah, I'm just having two more questions from Nikhil there. How does Huawei market support REST-based system?
Temporarily, we don't support REST API. Yeah. And we are Huawei mobile services, so we only support the phones. Yeah, the Android phones, not the web things. Yeah.
Yeah, that makes sense. Yeah, and then so in comparison to Siri and Google voice assistant, how good is the ASR algorithm?
I recommend he to go to our website. Can I share my screen?
Yeah, please do.
Yeah. So you can test it because we have already opened our demo on the website. So what I'm gonna do is like go to our official website. It's develop.huawei.com. Sorry. How to move this? So once go inside this official website and click Huawei Mobile Services, and in Develop, just move your mouse on over the develop and say the ML kit in AI column. And here's the view documents. Click inside. View documents, and here we have the examples. You can download the APK to experience our capability, and if you want to use the voice, let me see which one is voice. This one. Voice. Yeah, it's in here. Text module. So you just simply scan the barcode to download, or you can directly download the APK. So you can install in your the phone and experience our capability. I think it's pretty good.
Yeah.
Because a lot of the CPs are already integrate our services, and the feedback is really good.
Great. Actually, if you could share that link on the chat, I can put it on YouTube.
Yeah, sure.
You guys can just access it directly.
I've started up there already.
Oh, have you? Oh, great. Cool.
Okay.
I think that's most of the questions. There's some questions about pricing, but I think they'll probably be in the documentation, or there's free quotas
Sorry,
for.
it would be free or something like that.
So you said that there's free levels and there's a quota to use the services.
Yeah, it's our strategy is like it's free on device side. So sorry, just I have to share my screen again. It's like this. I have marked so the blue dot is the cloud side. The how to say that? It's this color is device side, and red for both sides. So let's look at it. For text services, it supports both sides. So that means you can use it free or on the device side, and you can also you can either invoke from the device side or invoke from the cloud side. Yeah, but all the cloud side would have a quota, but device side it's unlimited free. Yeah. So it's like once you want to use document recognition from the cloud side, we can give you like here is the quota. Sorry. Yeah, here's the so it would be like 10,000 calls a month for text recognition if you want to call from the cloud side. But if you want to call from the device side, it's unlimited, free. Yeah.
Thank you very much. I'd like to thank.
I can copy this link to the chat box.
Yeah.
We encourage developer to invoke from the device side. Yeah.
Okay. Thank you. Well, we got Stephen to a close. Thanks a million for such fascinating presentations, Madeline, and the questions as well. Very, very insightful. yeah, so hopefully we'll be back again for one more meetup before the end of the year. And we'll be sharing details for that as usual on meetup.com. But yeah, thanks very much everyone for watching and participating with this. And we will see you again in a few weeks. Stay safe out there.
Thanks, everybody.